Assalamu alaikum warahmatullah. This is experiment 6. The name of this experiment is compaction test of soil sample. In this experiment, we are going to describe the dry unit weight of the soil sample. You can find the number of equipments are given here. This is mold and these are the parts of the mold. You can find the spatula, you can find the straight edge, knife, brush, hammer. This is base plate. This is the mold, the collar of the mold. That is mold. This is a straight edge or the cutting edge. Knife, hairbrush, hammer, standard compaction hammer. This is tray, mixing pan. This is tray with soil. Here you can also find the water with the dropper. This is oven, and using this oven we can find the dry sample. In this experiment, we have to compact the soil in the desired mold, and this compaction would be in 3 layers. In each layer, you have to compact 25 number of blows by using that standard compaction hammer. First of all, you have to take the weight of the soil sample, and it was previously determined the weight of the soil sample is 2.5 kg. These are the moisture can. At the end of the test, we have to take the soil sample in that moisture can. We took 5 points in our experiment, but in this time we are taking only 1, but in the experimental sheet we took 5 points to get the approximate or accurate result. Now we are fixing the mold. We are fixing the mold on the base plate. We are fixing the collar on the mold. Now this is the set of a cylinder of the mold. Now we are adding 325 gram of water. I repeat, this is 13% of the total sample. That means 2500 into 0.13 is equal to 325 gram. Now we have to mix the soil with the water. Now we are using the standard hammer, and the drop of the hammer should be 1 feet. This is free fall. And there is a mistake. We have to take the mold weight before starting the experiment, and we already taken the weight, so we can say that the weight of the mold is 2.682 kg. And we are preparing the second layer. This second layer should also be prepared with the help of the hammer. This is the finishing. Now we are removing the collar from the actual mold, as we are using this collar to removing the upper soil layer, which helps us to get the accurate result or accurate mold or the cylinder of the soil sample. Now we are removing the collar. You can see there are extra soil on the surface, so you have to cut it down with the help of knife or straight edge or the cutting edge. After smoothing the surface, we have to check the weight of the soil sample with the mold. You can see how to collect the weight of the mold plus the soil by using the balancing machine. From this mold, we have to take some soil in a designated can. First of all, we have to take the weight of the designated can. Then we have to pour some soil from that mold. After taking the soil into the can, we have to dry it into the oven for 24 hours. After taking the sample, we have to take wet again with soil sample and the can. this is wet soil sample, and whenever we are drying the sample, then we can get the dry weight of the soil sample. And in our calculation sheet we will see that by deducing the result we can find how much water was added in this soil. This is the moisture content. We see this is oven, and we have to input the wet soil sample into the oven.
This is the calculation for the compaction test of soil sample. In the data sheet, the soil sample is 3000 gram. The weight of the mold is 2682 gram. The height of the mold is 116.50 millimeter. That means 11.65 centimeter. The diameter of the mold is 10.21 centimeter. This is a serial number 1, 2, 3, 4, 5, and we are previously describing that we have to take 5 points in our experiment, and this is the can designation 20, 21, 22, 23, 24, 24, and this is random number. This is not related with our topic, so you can take it 1, 2, 3, 4, 6, 7, 8, 9, 10, or XYZ, etc. So first of all, we have to take the mold weight. These are the weight of the mold, and this is same for 5 experiment. This is weight of mold plus sample. After finishing the lab in our video, we have to take the weight, which is weight of mold plus sample. This is 4.244. So if we are deducing from this value to this value, we can find the weight of the sample. This is 1.562, and this weight of the sample is in kg, and we have to convert it to the pound. So the pound is 3.436. By using the equation, we can find the moist unit weight, the weight of the sample divided by the volume of the mold. How can we determine the volume? This is cylindrical shape and cylindrical in shape, so by using the height and diameter we can find the volume of the mold. So the moist unit weight of the soil sample is weight of the sample divided by the volume of the mold. This is 10.19. Now after the experiment, we have to calculate the can designation. We have to calculate the weight of the can. The weight of the can for 20 or 21, 15.2 or 16.8, and simultaneously this is 22 for 15.5 gram, and so on. The weight of the can plus weight sample is 53 gram. After removing from the oven for a while or for 24 hours, the weight of the can plus dry soil is 49. In the previous day it was 53, and now this is 49. So the weight is water. So the presence of water in the sample is 3.1. This is 53 minus 49.9. This is 3.1. And the weight of the dry sample we can find, like this is weight of the can plus dry sample, and this is the weight of the can. From these 15.2 and 49.9, we can find the weight of the dry sample. This is 34.7. 49.9 minus 15.2, we can find 34.7. Simultaneously, we can find the moisture content. This is WW divided by WS. This moisture content into 100%, 88.93%. And simultaneously, we can find the dry unit weight of the sample. This is 0.227 pound per feet cube. And inputting all of these values in the graph, where the x-axis denotes moisture content, that means W, and the dry unit weight, this is here. We can find a graph like this. The peak of the graph is denoted as the optimum moisture content and the maximum dry density. This is the optimum moisture content, this is the optimum moisture content, and this is the maximum dry density. For our graph, the optimum moisture content is 17.7% and the maximum dry density is 0.305 pound per feet cube. This is the end of this experiment. I repeat, the result of this experiment is the maximum dry density of this soil is 0.305 pound per feet cube for the moisture content 17.7%. This is the maximum value. So this is the end of this experiment. Assalamu alaikum warahmatullah.